Chapter 1, Introduction to TypeScript. In this chapter, we'll explore what is TypeScript, setting up the environment, first TypeScript program, did you know? Imagine you're building a skyscraper. You wouldn't start without blueprints, right? Similarly, TypeScript acts like a blueprint for your JavaScript code, ensuring everything fits together perfectly. At its core, TypeScript is JavaScript with a twist. It's like JavaScript with extra features that help you write more reliable and maintainable code. For example, Airbnb employs TypeScript to manage a large codebase efficiently by reducing runtime errors and boosting developer productivity. Without TypeScript static typing, you'd be more prone to runtime surprises, like undefined behaviors that could crash your apps. A common rookie mistake is underestimating the power of TypeScript's type system, which can fundamentally change how you approach code organization and error handling. Imagine you want to build the next big thing like Airbnb or Netflix, but you need a robust language that offers both flexibility and safety. TypeScript is here to bridge that gap. To dive in, you start by installing Node.js, which acts like the kitchen for all your JavaScript ingredients. After this, you'll use npm to globally install TypeScript, which is akin to adding a new power tool to your coding toolbox. With the groundwork laid, you can create your @ts file and start drafting your masterpiece. Finally, you'll compile it to JavaScript, the language your browser happily understands. Forgetting to compile or attempting to run the TypeScript file directly can lead to confusion, much like trying to drive a car with an empty tank. Imagine you're setting up an event and need to keep track of attendee names accurately. You wouldn't want to mistake a name like Sam for a phone number or even a date, right? That's where TypeScript shines by letting you specify data types, ensuring you treat a name as a string and nothing else. In our example, we start by declaring a variable username of type string and define a function greetUser, which also expects a string. It ensures that when we call greetUser, we're passing the correct type, avoiding runtime errors. This step is vital for building robust applications by catching potential errors during compilation, not execution. A common pitfall novice developers face is neglecting type annotations, leading to unexpected behavior in larger codebases. By getting comfortable with specifying types now, you'll save countless debugging hours later. Most beginners assume they need to start from scratch to learn TypeScript, believing it's a completely different language. However, TypeScript's design philosophy is to extend JavaScript's syntactic capabilities without introducing new runtime behavior. In a real-world scenario, this allows developers to incrementally convert JavaScript projects into TypeScript by simply renaming files from JS to TS and gradually adding type annotations. Understanding this incremental approach revolutionizes how we adopt TypeScript. It becomes a much less daunting task, encouraging more projects to harness improved readability and error-checking benefits of TypeScript over time. Chapter 2, Basic Types and Variables. In this chapter, we'll explore primitive types, type annotations, type inference. Did you know? Imagine you're building a website for an online bookstore. You need to know if a customer is logged in, the prices of books, and the titles of the books. This is where primitive types come into play in TypeScript. They're the fundamental building blocks, such as numbers for book prices, strings for titles, and booleans for login status. For example, when you open your shopping cart on Amazon, the system uses these primitive types to know exactly what to display. Without these types, managing data becomes chaotic and error-prone, leading to all kinds of bugs. A common mistake is mixing data types, like trying to add a string and a number, which TypeScript helps us avoid. Imagine you're trying to catch an error in a massive project and you're pulling your hair out because everything looks fine. Type annotations can be the detective at your coding crime scene. They give you the ability to say, this should always be a string, nothing else. Think about how Netflix can instantly recommend personalized shows based on what you've watched. Type annotations ensure that the data Netflix uses is consistent and valid. Without them, communicating the wrong data type could lead to a broken recommendation system, annoying countless viewers. Making use of type annotations is like adding guardrails to your code, safeguarding against unexpected values and maintaining clarity. A common mistake to avoid is overcomplicating things. Keep your types simple and reflective of your data's real behavior. Imagine you're designing a building without knowing the exact layout initially. Wouldn't it be helpful if tools could predict structural needs and guide you accordingly? TypeScript's type inference works similarly by predicting the data type of your variables. For instance, when you declare let name equals John, TypeScript knows it's dealing with a string. This magic happens behind the scenes, significantly reducing your workload while minimizing errors that might occur from mixed data types. Without type inference, your code could quickly become littered with explicit type annotations, making it cluttered and hard to read. It's like having a smart assistant who clears the unnecessary clutter, improving the overall efficiency of your coding process. Imagine you are coding a game with a score tracker that uses primitive integer types, and suddenly your player's score jumps from an all-time high to an oddly negative number. This happens because of integer overflow, a concept that unexpectedly loops the highest integer back to the lowest one. Most beginners assume an error or a crash will occur when overflow happens, but it quietly circles back in what's known as wraparound. Understanding this quirky behavior is crucial for debugging and correctly handling calculations, especially in systems requiring precise numerical accuracy, like banking software or scientific computations. Great work finishing this chapter. Here are the key takeaways. Boolean values represent true-false states, useful for conditions like checking if a user is logged in. Type inference lets TypeScript deduce variable types without explicit declarations, like guessing that let age equals 5 is a number. Chapter 3, Functions and Interfaces. In this chapter, we'll explore function types, optional and default parameters, interfaces in TypeScript. Did you know? Imagine you're at a restaurant ordering a burger. The chef knows it comes with standard toppings like lettuce and tomato, but you can choose extras like cheese. In TypeScript, similar flexibility is achieved using optional and default parameters in functions, allowing you to customize behavior without overwhelming the function with unnecessary arguments. For instance, a company like Airbnb may use this to create user accounts where most users are guests by default, but can optionally be hosts if specified. Without this feature, you'd be forced to always specify every parameter, cluttering your function calls and cluttering your code. It's a powerful tool that enhances code readability and flexibility by allowing simpler function calls. But remember, it's easy to mix up argument positions, especially when dealing with multiple optional parameters. Align optional parameters toward the end to avoid confusion. Imagine trying to build a Lego set without the instruction manual. That's what coding can feel like without interfaces in TypeScript. Interfaces act as a clear guide that defines exactly what properties and methods an object must have, much like how an instruction manual ensures every piece is in its place. When Spotify developers work on different parts of their app, they use interfaces to ensure components like playlists and user settings integrate seamlessly. Without these contracted agreements, the code can get messy quickly, leading to bugs and mismatches. In a large team, they prevent massive confusion by enforcing structure and consistency. Remember, the beauty of interfaces is not just in setting expectations, but in revealing errors early before they become costly mistakes. Imagine designing a function to track product sales, where a default currency is set using a global variable. You might expect the default to stay consistent, but if that global variable changes after you define the function and before you call it, then the function uses the new value at invocation time. This can lead to unexpected results if you're not careful. Understanding this behavior is crucial because it affects how you manage side effects and reusability. It fundamentally changes how you should think about and handle global state and function defaults. Chapter 4, Classes and Modules. In this chapter, we'll explore understanding classes, inheritance, using modules. Did you know? Imagine you're shopping for a new car. You don't just think about the color, you consider its make, model, and year too. In TypeScript, A class allows you to encapsulate such data and behavior into a blueprint, making your code more organized and reusable. Above, you see a simple car class with properties and methods. Companies like Uber often use classes to model their fleets, keeping track of thousands of vehicles efficiently. Without classes, handling complex data structures would be cumbersome and error-prone. Remember, one common mistake is to forget initializing all properties in the constructor, leading to unexpected undefined values. Imagine you're at a car showroom looking at different vehicles. Now think of each car brand as a base model and each car model as a specialized variant. That's what inheritance in programming is like. In our example, we start with a general vehicle class that has a method to start a vehicle. A specific car class then inherits from vehicle, allowing us to create unique car types, like a Toyota Corolla. Without inheritance, you'd have to rewrite the same logic over and over for every type of vehicle, making your code repetitive. Remember, overusing inheritance can lead to overly complex systems that are hard to manage, so keep it simple and smart. Imagine you're organizing an event and need to coordinate multiple tasks. Instead of handling everything yourself, you assign jobs like catering, decoration, and sound setup to specialists. In the programming world, modules work the same way. They allow you to organize code into separate sections, making it easier to manage, much like delegating tasks to different teams. For instance, Facebook breaks its massive codebase into modules so engineers can work independently on features like newsfeed without stepping on each other's toes. Without modules, your code can quickly become tangled and hard to manage, much like an event with no clear delegation can turn chaotic. Remember, a common mistake is to clutter a single module with unrelated functions. Instead, focus each module on a specific responsibility for cleaner, more understandable code. It's common to think of modules in object-oriented programming as mere collections of methods that enhance the capabilities of classes or handle namespacing. But did you know that modules can actually change the behavior of classes dynamically, including their static methods? For instance, using the extend method allows a module to inject class methods, effectively changing the core behavior of a class without altering its codebase directly. This concept is particularly powerful in large-scale applications where you want to inject functionality without subclassing. Understanding this makes you rethink how you can use modules for clean and flexible code design, providing powerful alternatives to traditional inheritance hierarchies. Chapter 5, Advanced Types. In this chapter, we'll explore intersection types, union types, type guards. Did you know? Imagine you run a small startup where team members often wear multiple hats. Your office manager, for instance, also handles IT roles. With intersection types in TypeScript, you can create a single object representing the characteristics of both roles, say an admin and a user. In the shared code snippet, you'll find how we define interfaces for a user needing login credentials and an admin handling roles. When two roles merge into one as Alice Miles, the function login supports both aspects, inputting credentials and understanding roles. This flexibly handles multifunctional team members, letting developers maintain clear, organized code. Forgetting to intersect these types could lead to messy, repetitive code and potential functionality gaps. Imagine you're building an app like Netflix, and user profiles can be identified by either an email or a username. Instead of restricting a user's input to just one type, you can use union types in TypeScript to allow variables to accept both strings and numbers. For example, a function handling user login might need to deal with either their username, which is a string, or their user ID, an integer. Spotify does something similar by allowing users to search with either song names or artist identifiers. Without union types, you'd write repetitive and less maintainable code because you'd need separate functions for each data input type. Embracing union types makes your code more adaptable and cuts down on redundancy. But it's crucial to handle these flexibly with careful validation to avoid runtime errors. Imagine you're managing a busy cafe and each barista has a specific skill set. One can make espresso, another latte. Type guards in TypeScript are like assigning the right barista to each order. They help ensure your code only allows operations that make sense for the specific type of data you're working with. For instance, Netflix might use them to ensure movie ratings are numbers before performing calculations. This prevents bugs that could crash your app or display incorrect information. A common mistake to watch out for is neglecting to cover all possible types, leading to unexpected behavior. Remember, type safety is like a good safety harness. It's essential when you need it most. It's a common misconception that intersection types in programming languages always broaden possibilities by combining features. In reality, using intersection types with incompatible constraints, like a string with a number, results in a type that can't exist, a void that can't be instantiated. Imagine you have a vehicle dealership and try to create an electric and diesel car simultaneously. This reveals how computer languages enforce realistic constructs, ensuring that combinations are only valid if logically possible. Understanding this deepens your grasp of type systems, guiding you in crafting complex yet valid type relations. Great work finishing this chapter. Here are the key takeaways. Union types allow variables to hold multiple types like a number or a string, making code flexible and adaptable. Type guards act like security checks in code, ensuring variables are the expected type during execution. Chapter 6, TypeScript Tooling. In this chapter, we'll explore linting and formatting, debugging TypeScript, build processes. Did you know? Imagine opening a code file, and it feels like walking into a chaotic room. Linting and formatting tools like ESLint and Prettier act as your virtual Marie Kondo, tidying up the code and bringing harmony. ESLint lints your code by identifying problematic patterns or inconsistencies, ensuring the JavaScript or TypeScript code is not just correct, but also consistent with team standards. Companies like Airbnb leverage such tools to standardize code bases across a wide range of developers, ensuring new code blends perfectly with the existing one. Without these tools, your team might spend unnecessary hours fixing trivial issues or decoding each other's code formatting quirks, which could lead to major inefficiencies. Always remember, consistently well-formatted code is not only more readable, but is easier to maintain and debug, preventing costly errors down the line. Imagine you're building a crucial feature for your application, but it just won't work as expected. Enter TypeScript debugging, a powerful ally in your coding journey. With TypeScript and Visual Studio Code, debugging becomes a seamless process that starts by setting up a configuration. Consider how developers at Microsoft employ these tools in Visual Studio Code to efficiently debug their own and contribute to open-source projects. Without effective debugging, you may become entangled in a web of errors, with no clear path to resolution. A common mistake people make is neglecting to utilize the tools at their disposal, such as setting breakpoints, which can illuminate areas where logic goes awry. Remember, even a small proactive step can prevent a giant debugging headache later. Imagine you're working at a startup and your team is still using plain JavaScript for everything. As your codebase grows, maintaining it becomes a nightmare due to type errors only caught at runtime. That's where TypeScript tooling dramatically improves your workflow. By starting with installing TypeScript through npm, then configuring it with a tsconfig JSON file, you set clear rules for how your TypeScript should behave. Next, you build your project by compiling TypeScript to JavaScript. This automatic transition catches many potential errors early. Bundling the generated JavaScript using tools like Webpack makes the output efficient for deployment. Finally, integrating this build process into your CI/CD pipeline means every change is automatically checked and compiled, ensuring nothing breaks during production deployment. Jumping into TypeScript can seem daunting, but following these steps avoids the common pitfall of manual, error-prone processes. Many beginners assume TSLint is essential for linting TypeScript files because of its name. However, TSLint was deprecated in 2019, and the TypeScript community has rallied behind ESLint as the standard. An ESLint plugin specifically for TypeScript provides robust linting capabilities. This shift might surprise those who are gearing up to learn TSLint, but understanding this will allow you to leverage up-to-date and more versatile tooling. Embracing ESLint ensures better integration with JavaScript projects and a more consistent development experience.